Number 45. A model is made of a car. The car is 10 feet long and the model is 7 inches long. What is the ratio of the length of the car to the length of the model? So obviously we have feet and inches here, so I converted 10 feet to 120 inches, so 120 to 7. 46. Red and gray bricks were used to build a decorative wall. The number of red bricks over the number of gray bricks was 5 to 2, or the ratio. There were 224 bricks used in all. How many bricks were used? So the ratio is 5 to 2, so 5x plus 2x is going to be equal to our total, or 224. 7x is equal to 224. Divide by 7 and I get 32. The question asks about red bricks, so I know that red has to do with 5, so 5 times 32 is 160. 47. A salsa recipe uses green pepper, onion, and tomato in the extended ratio 1 to 3 to 8. How many cups of onion are needed to make 24 cups of salsa? So again, 1x plus 3x plus 8x is going to be equal to our total, so 24 cups. 12x is equal to 24, combined like terms. Divide, I get x equals 2. They're asking about onions, so I know that goes with 3, so 3 times 2 is 6. 6 cups of onions. 48. The two rectangles are similar. Which is the correct proportion for the corresponding sides? You can always check 4 is to 8 is 12 is to 24. So as we see that, I generally say it the other way, but this is an equivalent fraction. 49. In a diagram of a landscape plan, the scale is 1 centimeter to 10 feet. In the diagram, the trees are 3.1 centimeters apart. How far apart should the actual trees be planted? So I don't know that, so that's my x. I cross multiply, so I get 1 centimeter times x, and 10 times 3.1, or 31 feet. Number 50. State whether the triangles are similar. If so, write a similarity statement and the postulate or theorem that you used. So here we know to compare the corresponding pieces. I can see that both of these are isosceles triangles. So 5 compares to 7.5 in both of those sides, and then 8 compares to 12. I need to make sure before I can use the side-side similarity is that these three ratios reduce to the exact same thing, meaning they have the same scale factor. So indeed, they do all reduce to 2/3. So yes, these are similar by side, side, side. 51. Michelle wanted to measure the height of her school's flagpole, so that's x. All we need to do again is set up a proportion. So we have to make sure we're comparing the same pieces. So 48 is to 12 as x is to 5. Cross multiply and we get 20 feet. Number 52. What is the value of x given that PQ is parallel to BC? So we know that it breaks these again in proportional pieces. So 8 is to x as 12 is to 18. Or some of you might have said 8 is to 12 as x is to 18. It's still going to cross multiply to get 12x is equal to 144. And when I divide, x is 12. 53. What is the value of x to the nearest tenth? So when we have angle bisectors, they do break this up into corresponding pieces. So 12.2 is to x. 12.2 is to 5.1 as x is to 4.6. Again, cross multiply, and to the nearest tenth, 11.0. Find the length of the missing side. So here we're going to use Pythagorean theorem. It's a right triangle. What's very important is that we always put the hypotenuse in the C position. As long as you can do that, you can use Pythagorean theorem. So x squared plus 15 squared equals 17 squared. Simplify through. You should get x squared is equal to 64. One thing I always notice is that people might say that 17 squared minus 15 squared is 2 squared, and that's wrong. 15 squared is 225, 17 squared is 289, so we can't use that reasoning. Take the square root, so our missing measure is 8. Number 55. In this triangle, we notice that this is 45 degrees, so this makes this a 45, 45, 90. If we follow the pattern, or our model triangle for a 45, 45, 90, our legs are congruent, so if this is 10, so is this, and our hypotenuse is x square root 2, so in this case, 10 square root 2. Number 56. Again, another 45, 45, 90 triangle. So our legs are congruent, so if this is 8, so is this value. And our hypotenuse, 8 square root 2. Number 57. Here we have a 30, 60, 90. So across from the 30, if I drew this as my model triangle, across from 30 is my x value. My hypotenuse is 2 times x, which we have here is 10. So finally, the part across from the 60 is x square root 3, so 5 square root 3. Number 58, write the ratios for sine and cosine of x. So if we're coming from this angle, I know that this value, square root of 119, is my opposite, 5 is adjacent, and 12 is hypotenuse. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Same thing for number 59. This time I'm going from angle A, so here's my opposite, my adjacent, my hypotenuse. So sine is opposite over adjacent, 24 over 26, which does reduce to 12 over 13. And our cosine, 10 over 26, which reduces to 5 over 13. Last but not least, the law of sines. So here we have this triangle, and we always have to look, in order to use the law of sines, we need to make sure that we have big A and little a. So that's how I'm going to start the law of sines. The sine of 65 over 27 is equal to the sine of 21 over x. So it's always the measures across, angle and across. So here we'll cross multiply. So x times the sine of 65 is equal to 27 times the sine of 21. I'm going to divide by sine of 65, so that cancels. And I'm going to divide by the sine of 65. All I have to do is plug this into my calculator. 27 times the sine of 21 divided by the sine of 65. And to the nearest tenth, I would call this 10.7. Good luck on your exams, and if you have any other questions, feel free to email me over the weekend. There is my email.